Hey grade 7s and welcome, and this is the last video in a series of videos that we have been going through, and that is in mathematics, and that's on fractions. So in this video we'll mainly concentrate on examination questions on fractions. So look at different types of questions, and we'll look at questions from different papers and see how best we can solve them and how best we can work around fractions. So let's get into the first problem that we have, and that's coming from the 2014 grade 7 final examination. So here's the first question that we have, and the question is saying 3/2/8 multiplied by 1/2. So if you can remember what we had said, when you're dealing with multiplication of fractions, or you can pause the video and try working it out on your own, and we continue. So I was saying, when you're dealing with multiplication of fractions, what you have to remember is it's easy and it's straightforward. All you have to do is multiply the numerator by the numerator while the denominator by the other denominator. So what we get therefore is 3 multiplied by 1, and this is all over 8 multiplied by 2. Okay, so 3 multiplied by 1 gives us 3, and 8 multiplied by 2, which is simply the same as 8 plus 8, gives us 16. Gives us 16. So can this fraction be simplified any further? No. Now let's look at the options that we have. We've got A, 3/4, B, 2/5, C, 1/3, and D, 3/16. So the correct answer for question number 8 in the 2014 math paper is D. So therefore the correct answer is D. Okay, so the correct answer there is D. We can move on to the next question, and this is question number 45 from the same 2014 paper. So let me just write the question in case you cannot see it. So the question says 3/2/3 divided by 1 whole number 1/9. So you can pause the video and try working this out on your own. And if you remember what we did, when we were looking at division of fractions, and we had fractions that were mixed fractions, we said whenever you want to deal with them, the first thing that you do is convert the mixed fractions to improper fractions. Do you remember how to do that? Okay, so to do that, all we do is multiply the whole number part by the denominator. So for the first fraction that we have, we're going to say 3 multiplied by 3. Can do that. Then we add the numerator, so plus 2, then over the denominator remains the same, so we have 3 at the bottom. Are we together? We keep the division sign. We do the same for the other fraction, so 1 multiplied by 9, 1 times 9. We do that. Then we add the numerator there, so plus 1, and over, we keep the denominator that we have, over 9. Do you remember? Okay, so we say 3 multiplied by 3 gives us 3 times 3, so 3 plus 3 plus 3, 3 plus 3 plus 3 gives us 9, plus 2 over 3. Are we together there? We keep the division sign. 1 multiplied by 9. 1 times any number is that number, or rather any number multiplied by 1 is that very number. So 1 times 9 simply gives us 9. Then plus 1. And this is all over 9. Are we moving together, grade 7s? We can say 9 plus 2. 9 plus 2 gives us 11 over 3, then divided by 9 plus 1 gives us 10 over 9, right? Yes. Then, if you can remember well, we said when dividing, all we have to do is we change this division sign to multiplication and swap the denominator and the numerator of the fraction that follows the sign. So we will have 11 over 3. This changes to times. Then this goes on top, this comes down. We have 9 over 10. Right? Then once we get that, then we can go on with simple multiplication. So we say 9 times 11 gives us any number by 11. You should always remember that any number multiplied by 11 is just that number repeated. So we have 99. Then 3 multiplied by 10 gives us, 3 times 10 gives us a 30. Okay? So we've got that, but the answer hasn't been given as an improper fraction. It's been simplified to a mixed fraction. So we look for a number. Is there any number that can go into 99 and 30 without giving a remainder? Yes, 3. 3 can go into 9 how many times? 3 times. 3 can go into 9 how many times? 3 times. 3 into 30 gives us 10. So therefore we have 33 over 10. The answer is still in improper fraction, but we need it to be in mixed fraction form. So we say 10 into 30 into 33. How many times does 10 go into 33? 10 plus 10 plus 10 gives us 30. So it goes into 33 3 times with a remainder of how many? 3. And then we keep the denominator, which is 10. Is there any number, is there an answer similar to what we found there? And yes, we do have C. C is 3 whole number, 3 over 10. So therefore the answer is 3. C. Sorry, okay, I said 3. I said the answer is C. Okay, so when you're dividing mixed fractions, remember, firstly, convert them to improper fractions. Upon converting, change the sign. After changing the sign, swap the denominator and the numerator for the fraction that follows after the sign. Then go on with multiplication. So let's look at another example on fractions. We are still in the 2014 paper, and this is question number 59, and it says, Mrs. Chanda spent 20 kwacha out of 200 kwacha. What fraction of the money did she spend? Mrs. Chanda spent 20 kwacha out of 200 kwacha. What fraction of the money did she spend? So she initially had a total of how much? 200 kwacha. And she spent 20 kwacha out of the total 200 kwacha. So when you are illustrating, or when you are showing, converting from a sentence to fractions, what you need to remember is that the total, or the whole part of it that you had should always be the denominator. Then part of what you've gotten out of the total is on top. So she had, so we're going to put our horizontal line there. What she initially had was how much? What she had at the beginning was a 200 kwacha. So we're going to have 200 at the bottom. Then the part that she spent was 20. She spent 20 out of 200. Okay, do you see that? So Mrs. Chanda spent 20 out of 200. 20 out of 200. Is there a 20 out of 200 on our answers? We've got 1 over 5, got 1 over 10, 1 over 100, 2 over 25. So we have to find ways of simplifying this 20 over 100 to its simplest form, reducing it to its equivalent fraction, so that we can find out which one of these options we've been given is equivalent to 20 over 200. So when you've got zeros, you can simply cancel out the zeros. So you've got 1 0 here, meaning you can cancel 1 0 from the bottom there. You remain with 2 over 20. Have you seen what we've done? You cancel out the same number of zeros on top as you cancel out at the bottom. So we've cancelled 1 0, we cancel 1 0 from the bottom as well. Then we've got 2 over 20. Do we have a 2 over 20 there? No. So meaning we can simplify this even more than we have already. So we are going to say what number goes into 2 and 20 without leaving a remainder? What number can go into both 20 and 2 without leaving a remainder? 2 itself. 2 into 2 gives us 1. 20 divided by 2 gives you 10. So therefore you have 1 over 10. Do we have a 1 over 10 on any of our answers? Do you have a 1 over 10 on any of our answers? Yes, we do. And that is B. So therefore, for question number 59, this was a very simple question. All you have to do is illustrate this information given as a fraction. So you have 20 out of 200. Simplify that fraction to its simplest form and you'll get your answer, which is 1 over 10. Okay, we can move on to the next question. So now we're in the 2015 paper, and 2015 paper had question number 36 pertaining to fractions. And this is on subtraction of mixed fractions. So we've got 7, 1 over 2 minus 3, 1 over 3. So grade 7s, you can pause the video, try to work this one out on your own. So we said when we are subtracting mixed fractions, there are two ways that we can do this. We either work with the whole parts first, the whole number parts first, and then the fractions later, or we can convert them to improper fractions. But that's a whole long process. So I advise you to work with the whole number parts first, then later on work with the fraction part. So we've got 7, 1 over 2 minus 3, 1 over 3. So we take the whole numbers that we have. For this fraction, we've got 7. For that fraction, we've got 3. We subtract them. So we say 7 minus 3. 7 minus 3 gives us a 4. Okay? So this is our whole number part. This is the whole number part of our answer. This is the whole number part of our answer. Let's just remember that. Then we can move on to the fraction part. The fraction part, we've got 1 over 2 minus 1 over 3. So remember what we said on addition and subtraction of fractions. You only add or subtract them when they have the same denominator. If they have the same denominator, it's quite easy, it's quite straightforward, because all we look at are the numerators. We add the numerators or we subtract the numerators. But in this case, we've got two fractions with totally different denominators. So what do we do? So when we have totally different denominators, what we do is we multiply the two denominators. Do you remember that? We multiply the two denominators. So we say 2 times 3. Okay. Then these 3, then we say this denominator of this fraction here be multiplied by the numerator of that fraction, whilst this denominator of this fraction be multiplied by the numerator of that fraction. So we say this 3 multiplied by 1. So we have 3 times 1. We do that. Then what do we have there? A minus. So minus. Then this denominator multiplied by that numerator. So we say 2 multiplied by 1. 3 times 1 grade 7s is 3. Minus 2 times 1 is 2. And what do we have? 2 times 3 is? 2 times 3 gives us 6. So we have 3 minus 2 gives us a 1 over 6. So this is the fraction part. This is the whole number part. So therefore our answer is equal to the whole number part, 4. Then the fraction part, which is 1 over 6. And this should be our answer. Let's look at the options we've been given. We've got A, 4, 5 over 6, B, 4, 1 over 6, C, 10, 1 over 6, and D, 10, 5 over 6. Which one is the correct answer? Well, the correct answer is B, because B is the same as what we have there. So that's how we go about question number 36 in the 2015 paper, and the correct answer therefore is B. Let's look at the next question. And we are still in the 2015 paper. Question number 56 involves fractions, and this question says we've got 2 over 5. This is being added to 1 over 3. Pause the video, give it a try. And this is how we go about this question. So, are the denominators the same? No. If the denominators are not the same, what do? We multiply the denominators. So we have 5 times 3. Then multiply this denominator by that numerator. So we have 3 times 2. Then plus this denominator by that numerator gives us 5 times 1. And this is equal to 3 times 2 is 6 plus 5 times 1 is 5. And this is all over 5 times 3 is 15. Okay. Then we add that. 6 plus 5 gives us 11 over 15. Can this be simplified any further? No. Let's look at the answers that we've got. We've got A, 2 over 15, B, 3 over 8, C, 1 over 2, and D, 11 over 15. Which one is similar, or which one is the same as the answer that we found? And that is D. So therefore, the correct answer is D, which is 11 over 15. Next question. So we'll go through a number of questions, and I believe by the time we'll be finishing this video, you would have gotten enough knowledge on fractions, and I believe you can tackle any question that you would find on the topic of fractions in mathematics. So let's move on to the next question. So this is question number 60 from the 2015 paper, still in the 2015 paper. And the question says, Mr. Mwamba spent 10 kwacha out of 50 kwacha. What fraction of the money did he remain with? Mr. Mwamba spent 10 kwacha out of 20 kwacha. What fraction of the money did he remain with? So let's first find out what fraction of the money he had spent. Then that will help us find the fraction of the money that he remained with. So, okay, so let's do this. So let's say, what fraction of the money did he spend? He spent 10 out of 50. This is the fraction of money that he spent, right? Okay. Then how do you find the fraction of money that he remained with? Well, there are different ways of doing this. One of the ways that we can do this is simply subtracting 50. We subtract the 10 from the 50, which will give us the amount of money that he remained with. Then we form a fraction of that. Or we can simply say a whole number 1 minus this fraction that we have. But then that's a whole long process. So let's go with the easier way of doing it, which is by saying this 50 minus the 10 kwacha that is spent, and that will give us how much remained. So we say 50 minus 10. What is 50 minus 10? It's 40. So he remained with the 40 kwacha, right? So he remained with the 40 kwacha out of 50. So he remained with 40 out of 50. Can this be simplified? Yes. Remember I said when you've got zeros, the zeros can cancel. So there's 1 0 there, can go, as well as that 0 down there. And this gives us an answer of 4 over 5. Can this be simplified any further? No. Let's look at the answers that we have. We've got A, 1 over 5, B, 4 over 5, C, 2 over 5, and D, 7 over 10. Which one is the same as the answer we found? Which one is the same as 4 over 5? Which option is the same as 4 over 5? And that's B. So therefore the correct answer is B. So I know this question might have looked really complicated just at first sight, but it's really easy, and I believe you can attest to that. All you have to do is find how much he remained with, then form a fraction of that amount that he remained with out of the total amount he had. Let's move on to the next question. And here's the next question. The next question is number 32, and this is from the 2016 paper. Number 32 from 2016 paper. And the question says, divide 1 over 9 by 7 over 18. So we're saying 1 over 9 is being divided by 7 over 18. This is straightforward, eh, grade 7s? You can pause the video and give it a try. So to do that, we simply say 1 over 9. This sign changes, becomes times. Then we've got 18 goes on top. The 7 comes down over 7. Then we can move on and simplify this further. So the easiest way of simplifying this further is we can find a number that can go into opposite numbers. So 1 is opposite the 7, 9 is opposite the 18. So is there a number that can go into 9 and 18 without leaving a remainder? Yes, and that number is 9. 9 into 9 gives us 1. 9 into 18 gives us 2. So this is not really new, but then we've just come across this now. So I want to allow you enough time to process this, and so I'll just go through this once more. So we've said if we have two numbers that are opposite each other, denominator and the numerator opposite each other, that have a common factor, a common number that can go into both of them without leaving a remainder, then we can divide those two values by that common factor and simplify them. Okay, so meaning on this side we remain with 1 over 1 multiplied by, this side we have 2 over 7. Alright, then 1 times 1 gives us, or 1 times 2 gives us 2, then 1 times 7 gives us 7. Do we have any answer amongst the options given that is similar to 2 over 7? We've got A, 3 over 7, B, 8 over 27, C, 2 over 7, D, 18 over 63. So therefore the answer is C, 2 over 7. So let's look at a different question. So feel free to rewind the video and go try to get the information and try to do the questions on your own. And I would encourage you to always pause even before we start solving a question, so that you can try and see if you've understood and you're understanding what is going on. So for the next question, we have grade 7s. This is the next question that we have. We have 7 over 13 multiplied by 65. So now things are getting interesting, eh? So how do we go about this one? Let us think together. So we have 7 over 13, and this is multiplied by a whole number 65. Let us think. How do we go about this one, grade 7s? So if you can recall, in one of the videos we said any number, any whole number is the same as that number over 1. So any whole number is the same as that number over 1. And any number over 1 is simply the same as a whole number. So when you have 65, this is the same as 7 over 13 multiplied by 65, and this is over 1. Okay? Is it easier now? Okay, then what do we do? Well, we can multiply the 7 by 65, but then that seems like a lot of work. So what do we do to make our work easier? So remember what we just agreed upon in the previous video, in the previous question. We said when you've got opposite numbers and those numbers have got a factor, a number can go into both of them without leaving a remainder, then you can divide those numbers by that factor. So we've got 7 and 1, 13 and 65. Is there any number that can go into 13 and 65 without leaving a remainder? Is there any number that can go into 13 without leaving a remainder? Apart from 1? Well, 13 itself. So now can 13 go into 65? Let's try and figure out and find out if 13 can go into 65. So we're going to say 13 plus 13. 13 plus 13 gives us 3 plus 3 is 6. 1 plus 1 is 2 plus 13. 3 plus 6 is 9. 2 plus 1 is 3 plus 13. 9 plus 3 is 12. Carry 1. 3 plus 1 is 4. 5 plus 13. 2 plus 3 is 5. 5 plus 1 is 6. So 13 is a factor of 65. So how many times does 13 go into 65? 1, 2, 3, 4. Sorry for that. 4, 5. So 13 goes into 65 5 times. So 13 into 65 is 5. And 13 into 13 is 1. So now we have 7 over 1 multiplied by 5 over 1. So 7 times 5 gives us 35 over 1 times 1 gives us 1. And any number over 1 is simply that number. So we've got 35. Do we have 35 amongst our options? We've got A, 5, B, 35, C, 42, D, 455. So therefore the answer is A, not A. The answer is B, which has 35. So that's that about this question. Seems complicated, but in actual sense it is very simple and can be easily worked upon by us grade 7s who have understood fractions. Can move on to the next question. So now the questions are getting more and more interesting. These are things that you need to know even before you go into the exam room as a grade 7. So this is still from the 2016 paper. And the question says, 2016 specimen paper. The question says, this is question 40, says how many pieces of string, each measuring 2.5, that's 2 1/2 meters, can be cut from a string of length 20 meters. How many pieces of string, each measuring 2.5 meters, can be cut from a string of length 20 meters? So you can pause the video and try to think and work around this problem that we have. So this is how we go about it. So how many pieces of string, each measuring 2.5 meters, 2 1/2 meters, can be cut from a string of 20 meters, from a string of length 20 meters. So we're simply being asked to divide 20 by that. So this question is saying how many can be cut from that. So we're simply being asked to say 20, how many 2.5 meters are in 20? So 20 divided by 2, 1/2. I think I've made work easier for you. Can you work on that now? Okay, so this is the same as 20 divided by, we convert this mixed fraction to an improper fraction. So we'll say 2 times 2 plus the numerator 1, 1. This is all over 2. And this 20 is the same as 20 over 1. It's a whole number. Okay? So we have 20 over 1 divided by, what is 2 times 2? 2 times 2 is 4 plus 1. And this is all over 2. Then we have 20 over 1 divided by 4 plus 1 is 5 over 2. So let me rewrite it here. So we have 20 over 1 divided by 5 over 2. So 20 over 1, this sign changes to times. We have the 2 on top, 2 over the 5 down, over 5. So we go back to that principle, opposite numbers. We've got 1, 2, and 25. Any number can go into 20 and 5 without leaving a remainder. 5. So 5 into 20 is 4, and 5 into 5 is 1. So we have 4 over 1 times 2 over 1. 4 times 2 is 8, and 1 times 1 is 1. And 8 over 1 is simply the same as 8. So therefore, the answer for this question is 8, which is A. So answer is A, which is 8. So this question might have looked complicated, but all you are asked to do is simply divide the 20 by 2, 1 over 2. Okay, can move on to the next question. So we are still in the same paper, and this is question number 44. So this paper had a lot of fraction questions. This is question number 44, and I believe you can do this on your own grade 7s. Okay, so pause the video and give it a try. So the question is saying one whole number, so a whole big one, 1, 2 over 5 plus 2, 1 over 4. So give it a try, grade 7s. Let's see if we arrive at the same answer. So these are mixed fractions. So the easiest way to do this is work with the whole numbers first. So we are going to say 1 plus 2, and this gives us 3, right? Then you come to the fraction part of the question. We have 2 over 5 plus 1 over 4. So we've got different denominators. So in that case, what we do is multiply the denominators. We say 5 times 4. Then multiply this denominator by that numerator. We say 4 times 2. Then plus this denominator by that numerator. We say 5 times 1. 4 times 2 gives us 8, plus 5 times 1 gives us 5. This is all over 5 times 4 gives us a 20. This is equal to 5 plus 8. 8 plus 5 gives us a 13. And we have the denominator, which is 20. So this is the answer. This is the sum of the fraction part. But we don't forget to say we have the whole number part. So we put this together. We have this giving us whole number 3, that 3. Then the fraction part, which is 13 over 20. And according to the options we've been given, 3 13 over 20 is option A. So therefore the correct answer is A. Can move on to the next question. This is question 50 from the same paper. And the question says, arrange the following fractions from the biggest to the smallest. Do you remember this? This is like, this is from the second video that we had. And that was on comparing fractions. So us knowing which one is bigger and which one is smaller is dependent on us understanding the concept involved in comparing fractions. And we said to compare fractions to know which one is bigger than the other, we should make sure that the fractions we are comparing have the same denominator. Remember that? Make sure that they have the same denominator. So let's start with the first fraction. We've got 1 over 5. Then we've got 1 over 3. We're comparing all these fractions. We've got 1 over 7, or 7 over 3. Then we've got 8 over 5. So we have to make sure that these fractions, all 4 fractions, have the same denominator. And looking at the denominators that we have 5, we have 3, 3, 5. So we only have 2 denominators, which are 5 and 3. So how do we give them the same denominators? Remember, when comparing two fractions that have different denominators, we said we multiply either fraction by the denominator of the other fraction. So in this case, we have four fractions with only two different denominators. That's 5 and 3. So to give them the same denominator, we are going to multiply each fraction by the other denominator. What do I mean? Each fraction with a denominator of 5, we will multiply it by 3. And each fraction with a denominator of 3, we will multiply it by 5. So this one has a denominator of 5, so we'll say we'll multiply it by 3. So we're going to say the numerator by 3, the denominator by 3. Then this one has a denominator of 3, so we'll multiply the upper part by 5, the lower part by 5. This one has a denominator of 3, so we multiply it by what? By 5 as well, and by 5 there on top. Then this one has a denominator of 5, so we multiply it by 3, so times 3 times 3. So 1 times 3 gives us a 3 over 3 times 5 gives us 15. We move on to the next one. 5 times 1 gives us a 5 over 5 times 3 gives us 15. So you notice that all of them will have a denominator of 15. 7 times 5 gives us 35 over 3 times 5 gives us 15. The last one, 3 times 8 gives us 24. 5 times 3 gives us 15. So once we establish that the denominators are the same, then the next point that we have to make a certain is that we compare the numerators. Since the denominators are the same, then we compare the numerators to see which one is the biggest, which one is the smallest, and so on. So which one has the biggest numerator? It is this one, with the 35 on top and the 15 down. So this one has the biggest. So 35 over 15. So 7 over 3 is the biggest, which is, so 7 over 3 is the biggest. So we say it's number 1. Then which one is the second one? Is it this one? Is it that one? Is it that one? It's 24. So 24 over 15 is the second one. Then between the two, which one is the third one and which one is the fourth one? This one is the third one because it has 5, and this one is the smallest because it has 3. So 1, 2, 3, 4. So the biggest one should be 7 over 5, then followed by 8 over 5, then followed by 1 over 3, and lastly 1 over 5. So which option is in line with that? 7 over 8 is the biggest, or 7 over 3 is the biggest, then 8 over 5, then 1 over 3, and 1 over 5, and that is C. So therefore, the answer for question number 50 is C. So here is our next question. So I'm going to ask you to give it a thought and try to see how we go about such a question. The question is number 14, the 2016 final examination, grade 7 paper. The question says, what is 4 over 5 of 2 over 3? What is 4 over 5? So let me just write the question there. No, it's not so visible. What is 4 over 5 of 2 over 3? What is 4 over 5 of 2 over 3? So whenever you're asked to say what is that fraction of a certain number, all you're doing is multiplying that number by that fraction. So what is 4 over 5 of 2 over 3? You are being asked what is 4 over 5 of that number 2 over 3. So you multiply that fraction 4 over 5 by 2 over 3. Quite easy, eh? It looks complicated, but it's really, really easy. So all you're doing is multiplying 4 over 5 by 2 over 3. And this is straightforward because 4 times 2 gives us 8, and 5 times 3 gives us 15. Do we have an 8 over 15 anywhere? Do you have an 8 over 15 anywhere? A? No. B? No. C? C is therefore the correct answer. Really easy. And it's grade 7s. The 2017 paper had this question on fractions. Really easy question. And you can give it a try. The question says, a watermelon was cut into 7 pieces. If 4 pieces were eaten, what fraction of the watermelon were remaining? So it says a watermelon was cut into 7, so you have 7 pieces in total. And if 4 were eaten, what fraction of the watermelon were remaining? So if 4 were eaten, how many are remaining out of the 7? So we say 7 minus the 4 that were eaten gives us 3. So we are asked to say what fraction are remaining. So we've got 3. 3 pieces are remaining out of 7. Do we have a 3 out of 7 on any of our options? And that's B. So the correct answer is B, which is 3 over 7. We've got question number 31, 2017. Basically the same as what we've been going through. We've just attempted a similar question. And the question says, find 4 over 9 of 36. So 4 over 9. When you see the word of, it simply means multiplied by 36. So this is the same as 4 over 9 times 36 over 1. Opposite numbers, do we have any factors? 9, 36. Any number can go into 9 and 36 without leaving a remainder. 3, okay. So 3 into 9 is 3. 3 into 36 is 3 into 36 gives us 1 there. 3 into 6 gives us 2. So we therefore have 4 over 3 times 12 over 1. Opposite numbers, do we have any factors? 3 and 12. Any number can go into 3 and 12 without leaving a remainder. 3 itself. So 3 into 3 is 1. 3 into 12 is 4. 4 times, so we have 4 over 1 times 4 over 1. And 4 times 4 is 16 over 1, which is simply the same as 16. So the correct answer therefore is 16, which is B. So these are the last 2 questions we are looking at. And I'll give you time to try and do these on your own. Just check your understanding, try and do this on your own. And I will not explain, I'll just go through the working alone and we'll see if we can arrive at the same answer. So we can start. So we've got number 37, 1 over 2 plus 3 over 5. So I'll be quiet as well and I'll just be working through it and let's see if we arrive at the same answer. So this is the answer for the first one. I found my answer. Have you found yours? And then for the second one, we have 8. Okay, let me just write it this side. We've got 8, 1 over 2 divided by 2, 1 over 2. So I'm not going to be talking, I'll be quiet and I'll work through this. And you give it a try as well, and let's see if we can arrive at the same answer. Okay, go. Therefore, this is the answer, 3, 2 over 5. And according to the options we've been given, the answer is C. And I believe this is a wrap in this video. We've done so many questions. I don't even know how many questions we've done. And we've looked at different types of questions. And It's been fun having you, grade 7s, in this topic, and I can't wait to see you, or rather to interact with you in the next topic that we'll be looking at in math, and in the next topics that we'll be looking at in various subjects. So I hope you've understood the concept on fractions, and thank you very much for watching this video. Tell your friends more about Iskulu, and thank you very much. Have a pleasant day and see you in the next videos. This is a wrap on fractions. Thank you for being with us from the beginning till this point.